Hello friends, I'm Mohnish and you're watching Codex-Mohnish. So today we are going to simply change the color of our car in the Carla simulation, and we are also going to look through one interesting concept today. So let's get started and let's open our Visual Studio Code and let's go through the source code. Okay, so this is the wrong folder. I'll just open the folder once. Yeah, so we got it. So today is our project 223.py. So we are going to concentrate on this file and we're going to see the essence, the code which we have written. So we are importing libraries. We are getting the Carla EGG file, and we are importing Carla from there. So Carla is not a pre-built or like you can't install it using pip. So you get it with the Carla installations here. So I'll just show you 1 second. So you see you have a Carla UE4, I think. No, this is not a file. So you have Carla and you have a dist folder. In that you have this EGG file. So we are importing the Carla from this file. So that's why we are trying to get the path and we are trying to get it. We are checking if it is Windows or Linux, and if there is any error, we are just passing it and we are importing Carla. And we are creating an actor list. So we are going to append all the actors. As so in Carla, everything, each and everything you see, a car, wall, building, bus, the camera sensors, radar sensors, lidar sensors, everything is an actor. So we are just going to append these actors in a list. So when we are going to terminate the program, like we use Control C to terminate the program. So we are going to delete one by one all the actors using the actor.destroy function. And then we are going to go through our try and except block, and these functions will come while we are going to try a block. So I'll explain that time. So we are trying to connect to our local host at 2000 port. So 127.0 dot point like 0. This IP is the local host, and this is the port. And we are setting the timeout at 10 seconds. So if at 10 seconds, like if it does not connects between 10 seconds, then the program will terminate. And the world, we are getting the world. So we are getting the map, like blueprint of the world, like what is the world, the which map and all that. And then we are getting the blueprint of the world. So this will contain all the actors, roads and everything in the map. And then we are setting the car model. So from that blueprint, we are trying to filter model 3. So model 3 is a car from Tesla, and we are trying to set the 0. So this is will be the first car in the model 3 list. And now we are going to see the uh, way how we are going to give colors. So model 3 car. So if I show in here, so model 3 in Carla image. So you will see it's mainly blue, like it's like this, like in Carla. This is the original color given, but sometimes we may want to give it a special color. So that we can give the colors using the attribute color, like. So we are not setting this attribute for the drop vehicle. We are going to set this attribute for the car model. So that's a point to be noted. So we are getting the blueprint of world and filters. So this is the car model to which we are going to set the attribute color. And drop vehicle, we are going to spawn. So drop vehicle is what we are spawning. So we are in the drop vehicle contains the car model and the spawn point as the parameters. But the car model has the car, like which car are we going to use. So we are going to apply the color on the car model variable and not on the draw vehicle like variable. So we are setting the attribute color. So color is the attribute and we are setting the car color. So in car color we kept 180 comma 180 comma 180. So it's a RGB code. And you see there's a blue one, like there are two types of blues, and so you can explore these. So these are some color codes which are given. uh, so you can use these colors and you can experiment the color environment, uh, how the color goes. And now we are going to spawn a vehicle. So very simple at 31 spawn location. So in this video we are going to use town 2 map. So I'm going to show you how to change the towns. So in Kala we have 5 towns, so we'll be discussing that later. And we are setting our camera location rotation. We are doing this for the last couple of videos. So if you are not able to understand this code, you can watch the earlier videos. You can see the playlist at the end of the video or and else. And we are setting the radar sensor at generate radar blueprint. And then let's go. This is our radar blueprint function. So we are calling a blueprint library like as parameter. So that parameter is given as get blueprint of the world. So this one, so this is the parameter, and from that we are getting the radar blueprint. So radar blueprint is a variable. So in that we are getting the radar sensor dot other dot radar. So this is how you call a radar sensor in the Carla, and we are setting to zero. We have one the first sensor, and like it's our first sensor, and we are setting the FOVs horizontal, vertical, and points per second. So points per second is like radar sends waves, like waves, like which try to touch an object and come back. So the time, like we are getting four parameters: depth, altitude, azimuth, and others, and velocity. So we are getting those four parameters. We'll be seeing that. And so this points, so these are the number of waves, like the at when we get return, like when waves are returned, so we'll get 15,000 points of the image. So when we visualize it using nmap like Mayavi or other libraries, so we can get 15,000 points. So that's points per second. So and range is like the distance you want, like range, like from 0 to 20 meters from the car, not from the car, it's from the sensor. So it also depends where you implant the sensor in the car. So points per second is simply when you try to plot a graph or anything, you can see that visually, but in the code, you're going to get 15,000 data points every time the radar sensor gives the data. So we'll get 15,000 data points. And now we are going to go through the next thing, which is sensor radar spawn point. So we are setting the spawn point uh, just in front of the car. So this location like gives in front of the car, like just front of the car, and we're attaching it to the car. So that's what happening, and we're going to listen to the radar like when there's a like detection happening. So we're going to listen, like listen function give us the data, so we'll get the radar data as a return value of the listen function, and we are going to give a lambda function. So radar data is what we get from the listen function. So we are going to set a lambda function here, and we are going to call the radar callback function, and we are going to give this radar data as a parameter. So here radar data is a parameter here. So we are making a dictionary distance name dictionary, but here we are not getting the name of the vehicle. We are just setting the distance. So for detection in radar data. So here we are having radar data. So in that for every detection, we are going to set the distance in the dictionary distance and detection dot depth. So here, if we print the detection, like I'll show you when we are doing this. So I'll use a f string detection, and we'll just do detection here, and we'll just keep a slash in, like double slash in, so it will be separated, segregated from everything. Here one more slash in. Okay, so after that we are setting the depth. So we get four parameters. So from that depth is the distance, not the depth, like not what we mean here. And we are writing a if condition to check the distance if it is between 3 to 6 meters. So we are going to call this like if condition to check if the distance between the object which is in front of it is 3 to 6 meters. So depth is the distance as we discussed. So we are checking that distance. So we could actually directly keep detection or depth, but this is like we are just adding up variables to make it more readable, and we are setting if it is greater than equal to 3 or less than equal to 6, then all it is going to happen. So the range we are giving here is from 3 to 6 meters of the distance from the radar sensor, and we are setting a drop vehicle, and we applied a control, and we call out a vehicle control handbrake equals to true. So here handbrake is true means we are setting up the brakes. So if there is something in the distance of this, so we don't want the car to crash or hit that thing. So we're going to stop the car and we're going to print brake and waypoints. So this was the interesting thing which you are going to learn in this video newly. So waypoint, so we are going to world. So world is this variable which has the client.get world. So it's the actual total world, the map, it's loading the map. So from that map, we're going to get a waypoint. So waypoints is like where your vehicle is, like on a driver lane or a shoulder lane or sidewalk. So we are going to understand this. So it has three parameters. So where is like where you want to check the waypoints. Like so we are going to check where the drop vehicle is there. So we're setting the location and project to road equals to true. So project to road means like you want to like check if the vehicle is like only when the vehicle is there on the road or not. So that time only we are going to check it. So we are setting it true. And lane type. So what lanes do we want to check it for? So lane type dot driving. So you know what a driving lane. So on which we drive, and lane dot shoulder. So shoulder is this lane. So in India it's meant for emergency purposes. So if you have went on highways, so if any car crashes or anything, they are sent to this lane. And sidewalk is just like the sidewalk like for pedestrians. And a setting like we are printing the lane type and we are checking the traffic lights if. So our first priority is to stop the vehicle if there is something. Then we are going to check for traffic lights. So traffic lights is a function. So we are is that traffic light is a function. So it will check if the vehicle is at traffic light. And we are going to set the drop vehicle dot get traffic light function. So we'll get the traffic light which color. And if it is red, it will stop, and else it will just move on. And then we are appending the sensor, then we are checking traffic lights just like that, and we are setting a sleep, and we are destroying the vehicles. And now let's see the execution. So if the video is little long, so I'm sorry for that. And now let's so I'll not use the Visual Studio terminal, I'll use this one. So I'll just cd, I'll just go to our Windows no, okay, Windows no editor folder. So it has all the stuff with Carla, and we are going to run our Carla, and we are going to set the quality and level to low because we respect our resources. And now we are going to go through our Python API and project code folder. So we are in the project code folder, and we are going to run the Python uh, project 223.py. Okay, no module name Carla. Okay, so I need to activate my 3.7 like in Python environment. So it's stored in the a virtual environment of Carla. So I have to activate that. And like this long thing is okay. I'll just change this prompt Harish at Carla percentage. Okay, so I just cut shorted this thingy, so we can like it's easier to do the stuff. Let's activate the base again, and I'll just run the Carla. Okay, so you see, here as we printed. Okay, wait. Why isn't this stopping? I just do Control C. So as we printed the radar detection here, so we are getting the velocity, azimuth, altitude, and depth. So from that we are taking the depth. So depth is the distance, velocity is velocity, azimuth is like angle from up to down, and altitude and all that. So this is understandable. So I'll just comment that line. Okay, so where did I print it? So okay, so comment it. And now let's CLS and okay, I'll set the colors to some. Okay, now let's go through our Python 223.py and let's see the output on our Scala window. Okay, before that, let's spawn pretty some few vehicles here. So I'll just okay, I have to do all that thing again. CD Windows or no ed. Why do I do this? CD Windows, no editors, CD Python API, CD util, and now we are going to conda act. You wait the Carla environment and Carla, and now we'll wait for it. And now we are going to set the map to 2. So here we are having a file name as config in the utils folder. So if you have seen my arc parser video, then you understand what this map is. And now we'll just set the map to 2. Okay, so map is set to 2. As simple as that. And now we'll just spawn a couple of vehicles. So we have a spawn npc uh, file in the example. So we'll use that Python spawn and wait, spawn spawn npc, and we're setting it to 50. And now let's move it, and we'll just run this code also. And now let's see the output. So your first thing we see the Carla like this becomes silver. So now you see it really going near, and see from the bushes. So you see the car stopped, and it's saying our car lane is driving lane. So as like we can't just bash into the sidewalk, or we don't have a shoulder lane or kind of here, so we can't say like we can't verify that, but we can see that the code is running properly. So that was it for today, friends. Thank you for watching the video. If you like it, like the video, subscribe the channel, and share this video so everyone gets this informative videos. And that's it today. Bye bye.